All right, this is our last lesson for Intro to Chemistry. Our first topic for today is derived units, and this just means that you have multiple parts to the unit. So for example, if you're driving a car, you would talk about your speed in units of miles per hour, and that's 2 parts. In this example for volume, length times width times height is 3 parts, so you get meters cubed. And this little conversion right here is actually really useful in AP Chemistry. So be careful with that and just try to recognize that 1 centimeter cubed is the same as 1 milliliter. So if you picture a centimeter is about the width of your pinky, so picture a cube that is where all the sides of the cube are the same width as your pinky. That amount of space is also equal to 1 milliliter. And a lot of times if you're trying to find volume of something, instead of trying to measure the sides, we'll use what we call water displacement. We actually did this in my honors class if you had me for honors chemistry, where we dropped several metals into water and we watched the water level go up, and the difference in the water level is the volume of the object. We can use volume and density is important because it's an identifying feature of pure substances. So we know the density of things like copper and water and any pure substance that you can think of. So we can identify something based on the density. So if something is a clear liquid and it has a density of 1 gram per milliliter, it's probably water. And you can do calculations with this just using that equation. So density, it makes a heart. Put mass on top and volume on the bottom. And you can just plug in the numbers. So here it says we've got the volume is 5 milliliters and the density is 13.6 grams per centimeter cubed. So first of all, it looks like our units are not going to match because one is in centimeters cubed and one is in milliliters, but remember a centimeter cubed is the same as a milliliter. And then you can just solve for x to get the mass. All right, the next thing is classifying matter. So first of all, matter is defined as anything that takes up space and has mass. So most things that you can think of are made up of matter. They're made up of stuff, but some things in your room probably are not. So for example, the light coming out of your lights, the heat, any kind of energy is going to be something different. And for states of matter, we talked about this in our review, but the one you want to focus on mostly is gases because they're very different from solids and liquids. And to convert back and forth between these, you're going to change the interparticle attractions. So you're either going to form intermolecular forces or separate them, or interparticle forces is a better way to say it. All right, our next thing are mixtures. So mixtures means that you have 2 different things together, but they're not chemically bonded together. They're just kind of sitting together. And whether they're homogeneous or heterogeneous usually has to do with the size of the particles. So homogeneous mixtures have very tiny particles and they get dispersed equally throughout the whole thing. And so that would be something like Kool-Aid. If you make a solution of Kool-Aid and you pour 2 glasses, one's not going to be like really dark and one's clear. They're going to be about the same after you mix the pitcher together because it's homogeneous. And something different would be like a chocolate chip cookie. If you break it in half, you might have 2 chocolate chips and I have 3, so it's not mixed uniformly. So that's going to be heterogeneous. There are some ways that you can separate them. It's not too difficult to separate mixtures. Distillation is when you separate based on boiling point. So we talked about this with the vapor pressure curve. If things have different boiling points, something that boils at a cooler temperature will boil first, and you can separate it off of the thing that still hasn't boiled yet. Filtration is using filter paper. We did this in honors chemistry, and then chromatography we're going to do later on in this class as well. You can separate things. You may have actually done this in biology too. All right, that leads us to elements versus compounds. So these are called pure substances, which means it's harder to break them down. So an element means that it cannot be decomposed into a simpler substance by physical or chemical means. So you can break an element down into atoms, to individual atoms, but these are, they can't be decomposed into something simpler, basically. So these are the way you know something is an element if you're trying to identify it is because they are listed on the periodic table. So anything on the periodic table, if you're just talking about one of those things, that's going to be an element. A compound is when you take 2 different elements and you bond them together. And these are a lot harder to break apart than mixtures. So mixtures, we can separate those pretty easily using several different techniques, but compounds, it's really hard to separate those because the bonds are a lot stronger and they're actually bonded together. And compounds are things, if I ask you if something is a compound, the way that you probably can figure it out is if you know that there is a chemical formula for it, it's probably a compound. So things like, water is H2O, you know that carbon dioxide is CO2, glucose is C6H12O6, even if you didn't know those exact numbers, if you know that there is a chemical formula for it, that's going to be a compound. There is not a chemical formula for mixtures. They would have several different compounds. And this flowchart here can kind of help you break it down if you are a visual person, like to see how it's arranged. And during your progress check for today, you'll practice identifying several different things and trying to put them into the right category. All right, just a few more things. The next two words you may not have heard before, so you might want to highlight these two. Extensive properties versus intensive properties. Extensive depends on how much stuff you have. So how much something weighs, how long something is, that matters how much stuff you have. So that's going to be extensive. Intensive does not matter how much stuff you have. So the color of your shirt, whether it's your whole shirt or you cut it in half, it's still going to be the same color. So it doesn't matter how much you have. Same thing with like density is an intensive property because it's a ratio. So for example, water will always have the density of 1 gram per milliliter. Doesn't matter if it's 1 drop of water or 1 gallon of water, it's still going to be the same density. So that's going to be an intensive property. And our last topic for today is physical versus chemical changes. A physical change is when you change something about the substance, but not the chemical identity of it. So for example, you can cut a piece of paper in half, you can crumple it up, you can do lots of things to the paper which will change it, but it doesn't change the fact that it's still paper. A chemical change would be actually changing the substance itself. So when you light that paper on fire, it becomes new substances. It's no longer paper, and you can usually see that from lots of signs. There's things like color change. I listed them down there at the bottom. So color change, odor, sound. A precipitate, remember, means that a solid is formed, and you'll see a precipitate when it looks cloudy. And physical changes, you do have to be careful. I did it right here. This one right here and this one. These two, a lot of people have trouble with. When I say changing states of matter, I mean things like when you melt an ice cube, sometimes people think that's a chemical change. But the ice cube is made up of solid H2O. The water is made up of liquid H2O, but it's still H2O. So when you change from a solid to a liquid to a gas, you're not changing the identity of the chemical. You're just changing whether it's a solid, liquid, or gas. So be careful with that one. And same thing for dissolving. Dissolving is when you break something into such small pieces that you can't see them anymore. And a lot of people think that when you dissolve it, it disappears because you can't see it. But the particles are still in there. They're just have broken into very tiny pieces. So dissolving is not a chemical change. It's a physical change. And again, watch for those signs down here that a chemical change has happened. Chemical changes are hard sometimes because it's things like if you make toast, people think that toast is still bread, and it's actually not. And there's some signs. You'll smell the toast cooking, the toast turns color, and so those are signs of a chemical reaction. And it actually is a chemical reaction when you make toast. So use those signs to help you. And that is it for today.